Script. Hey everyone, welcome back to Leetcode Explained. Today we're tackling problem 3337, total characters in string, after transformations 2. It's marked as hard, but don't worry, we'll break it down step by step. Script. Here's the problem description. We start with a string of lowercase letters, a number representing transformations, and a list called of size 26. Each character transforms into multiple new characters based on the corresponding number in the list. The crucial part is this transformation rule repeats times, and the resulting string length can become massive. We need to find the final length, but just modulo 1 billion plus 7. Script. Let's walk through the example. Our string starts as is 2, and the list mostly contains ones, except for the last element. Script after the first transformation becomes because at index 0 is 1, so it becomes one character, starting from the next letter, which is similarly, becomes the 2 because at index 24 is 1. So it becomes its length is 5. Script. Now for the second transformation, becomes crew back up as second transformation rations the first. Becomes because at index 25 is 2, meaning it becomes 2 characters, starting from the next letter, which is then wrapping around to the second, also becomes concatenating these, we get then another resulting in the length is now 7. This matches the example output. Script. So our first thought might be, why not just do the transformations directly? Start with the string, apply the rule based on get the new string, repeat times. Script. But there's a big problem. If each character can turn into, say, 2 or 3 characters, the string length grows really fast. It can become exponentially long, and can be huge, up to 10 to the power of 15. Simulating this directly would take forever and eat up all our memory. We need a much faster way. Script. Let's try finding a better way. Notice something important. The transformation rule for a character like only depends on, and the value in the list corresponding to. It doesn't care what characters are next to it, or where it is in the string. This suggests that maybe we don't need to build the string at all. Script. What if we just keep track of how many of each character we have, like initially, we have 1, 1, 1, 2, and 0 of everything else. After one transformation, how do these counts change? Every adds some characters, every adds some, and so on. Script. This idea of tracking counts and seeing how a transformation changes those counts. That sounds like something we can model with a mathematical tool called a matrix. Script. We can represent the counts of the 26 lowercase letters as a list or a vector of 26 numbers. Then, we can create a 26 by 26 grid, our transformation matrix. Script. Think of this matrix. The columns could represent the original characters, say from Jide to the rows, represent the characters they might become. If character range X transforms into several characters according to at index, then in the column 4 we'd mark a 1 in the rows corresponding to the characters it transforms into. For example, if becomes Cruz Bassi and the matrix would have 1s in the row for script. So if we have our initial counts in a vector, and we multiply that vector by this transformation matrix, the result is a new vector containing the counts of each character after one transformation. Doing this multiplication times is like applying the transformation times. See your script. Multiplying a matrix by itself many times can still be slow if it's enormous. But there's a clever trick from mathematics called matrix exponentiation by squaring. Like script. It's similar to how you can calculate a number raised to a high power quickly by repeatedly squaring. This method allows us to calculate the matrix raised to the power of much faster, in time proportional to the logarithm of form. Script. So the overall plan is this. First, figure out the initial counts of each character in the string. Put these counts into a vector. Second, build the 26 by 26 transformation matrix based on the array. Third, use matrix exponentiation to calculate the transformation matrix raised to the power of kine. Finally, multiply the initial count vector by this powerful transformed matrix. The resulting vector gives us the counts after all steps. We just sum up these final counts. Remember to take the result modulo 1 billion plus 7, because the number can get very large, and that's our answer. Script. Alright, here's the C++ code implementing this approach. It uses a struct to represent the matrix and functions for matrix multiplication and matrix exponentiation. Don't get overwhelmed. We'll walk through the key parts. Script. First, we define a struct to hold our 26 by 26 array of numbers. We also define how to multiply two structures together. This is standard matrix multiplication, with modulo applied at each addition to keep numbers from getting too big. Script. Next we have the quad matrix power function. This is where the fast exponentiation happens. It starts with an identity matrix and repeatedly multiplies the base matrix by itself or by the result matrix, based on the bits of the exponent script. Inside the main function, we first create a vector called joq or quote to store the initial number of times each character from quotes 2 appears in the input string. Then, we build our quote transform matrix. For each original character indexed, we look at the corresponding number in Gossity index. This tells us how many characters it splits into. For each of those resulting characters, we increment the corresponding cell in the matrix column. The indices wrap around using the modulo operator script. Once we have the quote transform matrix, we raise it to the power of using our quote matrix power function. The result is called final transform. Then, we multiply our initial vector by this quote Finally, we sum up all the numbers in the number